So be better than the rest. That's what we're all here for, be better than the rest. First time I got on an elevator, it was an uplifting experience. The second time was a real letdown. That was the joke, okay? We're done with the humor part, you're like, oh, we can get on with stuff. It's like late Saturday, we're all just like, whatever. And I've done this talk many times, and for some reason I feel like I'm missing something today. You know how you leave the house, you're like, what did I forget? And then you get to work and then you left the garage door open. I just had that feeling. So GRPC is pretty cool. So hello. The first time I went surfing, I was 40 years old. When I was all growing up, I was like, I'm gonna learn to surf, I'm gonna learn to surf. Finally, when I was 40, we were at the Outer Banks. I'm like, I'm going surfing. Rented a board, went out, got lessons. First chance I got, I paddled up, caught a wave. I popped up, which is what you do, and rode it all the way in. And the instructor was like, he was talking to my kids, like, has he done this before? Like, I literally have never seen anyone do that first try. Like, never. And I was like, right, I skateboarded, so I guess that was the advantage. And then I'm hooked on it. It's just the greatest thing ever. It also has been scientifically proven as the best treatment for PTSD is surfing. That's an honest to God fact. The point of that is, don't be afraid to try new things. And GRPC is probably gonna be a new thing to try. I recently gave this talk in Denver, and the next day, a guy said, hey, I got permission to work to try it. I said, yes, I'm a thought leader, influencer. I got one person in 5 years to do this. And before I start my talk, I want to do a little Tony Robbins on you. So I can't go surfing here because I tore my cartilage and I'm getting it repaired in 3 weeks. And the past spring, this is real personal. I got real depressed because of my knee, because I'm real active. And I got so depressed I got like suicidal, because it was that important to me. And my wife said, you have to get it fixed. Went to the doctor, I'm getting surgery, everything's going well. The point of that is, I don't say to women, to guys, if you have a mental health problem, please get help. That's just a very personal thing, I just feel like I need to say it. But let's talk about importance. So on this end, you got poor little Sarah that has cancer. And this is the guy back in the corner. He goes, well, I write code. Oh, there is a woman. I beg your pardon. I didn't see it. So folks, not guys. So back here's the woman coder that's doing the stuff to fight cancer, right? She goes home from work. We found another breakthrough. And you're over here writing ticketing systems, like you're trying to put a QR code on a ticket at Disney World. And you come and it's like, And so you meet and you're here at the conference, like, what do you do? Oh, I'm working on cancer solving. What do you do? Ticketing systems. So obviously her job is more important, except in between here you have like banking, and here you have like car sales. So 2 years later, little Susie, is that her name? Her cancer's cured. So what's the first thing she wants to do? She wants to go to Disney World. Now what's the most important thing on the spectrum in her eyes? It's you with the QR codes. The QR codes let you skip the line and get on the ride first. And in between is the bank, because the father's happy, he goes, the bank gets a loan, buys a car, and they drive to Disney World. So that's my Tony Robbins moment. Don't let anyone ever tell you that your job isn't important, even though on the spectrum you might think it's not. Everything we do is the same importance and has the same result. We are all trying to do the same thing, and that is make life better for other people. So here's why you're here. That's why I'm here. This is why you're here. Currently, you're using REST, aren't you? Who's using REST? Hopefully, and okay, good. I'll just say every hand, all 70 hands went up. What is REST? There's problems with REST. There's problems with everything, isn't there? I mean, wouldn't it be nice? Right? See, it's not like this is really intriguing. What's he gonna say? Introducing GRPC. I wish it was called GRPC. I think that's so much cooler, or Gripic. I would. It makes life easier, supposedly, and it makes systems faster. That's why we're here. The goal of this talk is not to sell you GRPC. First of all, it's free. But it's not even to sell you on it. Like, I'm not a convert or anything. I just have learned some things about it, and this is just for you to, when you walk out, say, well, I'm not using that, it's stupid. Or walk out and go, hey, this is okay. Oh, what's this? Mine 24 hours are up. I hope this is the right code still. Or it's going to be a long... Actually, that's not true. I have everything running on localhost. So currently we're using REST. And that's kind of the de facto way of using web services. Right? Isn't that what I mean? Who here is still using SOAP? It's okay. Okay, that's cool. It's okay. The first time I used SOAP, I was like, this is awesome. Because it was a intranet Visual Basic project, and I could be like, I could reference it and a dot, and I get like IntelliSense, like this is awesome. And then I saw XML, I was like, ugh. So some people, well, we'll get into that, but REST, gRPC is like SOAP 2 or Corba, some people say. But the de facto way is REST. And what is REST? Stands for something. Who cares that? That's just, the reason I have this is because I went to a job interview and this real arrogant guy was like, well, do you know what REST is? I'm like, well, yeah, it's a technology of getting information like from basically a URL. He's like, what does it stand for? I was like, I don't know, I don't care. Representational state transfer. I'm like, good for you. I got the job and he got fired. It's an architecture, but I didn't know this until I got into this. Because I'm like, REST, everybody knows what it is. It's HTTP over TCP, right? You have a URL you go to and get something. That's just the way. I look at REST as a URL, like a location, something, a URI, whatever. You don't want, pick your one. But that's just how I see REST. It's like, well, it's just where you get, I put stuff, I understand. But it's not really a technology, it is an architecture. And it's limited to, in that context, to these verbs. And pedantic people will argue that there's some other verbs, that's fine. But usually the first, get, post, put, and delete are the most popular. Anybody ever messed with JSON patch? Oh my gosh. That was a job. It was, I did that in Rackspace on OpenStack stuff. The language is invisible, of course. Everything nowadays, it doesn't matter. I mean, really, we're past that. You got that bullet point. And it's only human readable. My REST is not, well, it's a machine talking, I know, but when you get into the specs, like you're looking at your program, it's human readable, it's not machine readable. Do you understand what I'm saying? If you don't, I'll show you later. And so there's an example. So what, just looking at this, we all know what it would do. Assuming it was a get, right? You would be getting customer number 1, customer ID 1. So this is to me, like when people say, what's REST? I just go to this. Here's the documentation from OpenStack, a RESTful interface. And when I say it's only human readable, this is an example. This is, to me, an example of what's wrong with REST. And the fact that if I didn't have this, I would have no way of knowing how in the world to do this. And plus, I have to like look at this while I'm coding. I kind of, okay, I see what I've got to do, all right. And meanwhile, down here, oh, by the way, to create, update, or delete a custom metadata, you have to use this header or name is like, what? Why is that down here? Why isn't it up here? Why isn't this just a parameter, like in my call? Why can't I just say metadata item is this and here's the new value? Well, why do I have to know this? That's a pain. Metadata keys must be treated as case insensitive. Oh, seriously? There's got to be a better way. So the problems with REST, it's only human readable. I think I've belabored that point. It's strings, so you have serialization, deserialization, that's a thing, right? I mean, it is. You have to have a library to serialize, deserialize. And who's in here is a .NET developer? It's okay, raise your hands, okay. So you have JSON.NET. Who in here isn't a .NET developer? Okay, good. Who in here is using Red Hat Enterprise Linux? Bunch of reprobates. He is. I'm kidding. I'm serious. I don't care. We have enough people using it. I'm doing fine. The method names are limited to HTTP verbs. So the stuff I meant to, remember earlier, is what is REST? Now we're finding out those are the problems with it. And of course, I'm saying they're problems, so otherwise if I didn't, this talk wouldn't have something to solve. So I'm going to solve these problems. If I felt they weren't problems, then I'd be like, well, what am I going to talk about? So wouldn't it be nice? It's like those commercials where it's like, are you fumbling with hoses? Like in a black and white, the guy's going like this, you know, and it's like, come on, that's not realistic. So obviously rest isn't that bad, or we wouldn't be using it, but I have to use hyperbole to get invited back to speak again. So wouldn't it be nice if machines could read the interface spec? Like if you read, like your IDE. So if you use Visual Studio, what should be like something dot, and up comes a list of methods. Like, wouldn't that be awesome? Instead of just like get, put, post. I mean, it might be like get customer. And then the parameter is customer ID. Oh, that would be slick. I bet I'm leading to that, right? Because I wouldn't be saying that. I bet you that's coming. What if you didn't need to use code to serialize and deserialize? That would be nice. Just rip those libraries out and forget about them. That's one less dependency, one less chance for bugs. It's just nice. And what if you could name your methods whatever you wanted, right? Like send confirmation email, or get customer, or update container metadata. Remember earlier that one? What if you could just make that a method and do it? And what if performance was way better? Someone told me, someone who worked at Google, said that they use it for everything. The G and gRPC is Google. He said it was 50,000 times faster. I don't know. It was my son. And I think he might have been just like, I don't know where he gets this given hyperbole stuff, but I think he was doing that. So let's talk about gRPC. It's in the Stubby program, and you'll see why Stubby. You'll see the stub. And I don't have a thing of what's bad about gRPC. I will mention some of them, but I purposely gloss over them, right? Because that's what you do when you're presenting something that you want people to see only the good. Is it SOAP all over again? That's the SOAP and Corba, the two. Oh, it's just SOAP. It's just Corba. Maybe. It is faster. It uses HTTP2, which I call H2, because otherwise it just takes forever to say it. And now I will pause to leave you all wondering what's next. Oh, it's so effective. It uses an open connection for the duration of the method. This is where the performance comes in. This is really slick. So instead of TCP and like packets just flying back and forth and connections opening and closing, you can open a pipeline. And you have a couple ways. You can use it like regular TCP, just like get stuff, like get a customer. But you can also stream like from the client to the server. Like you can just open like a pipeline and stream, and it's just like that. You can go the other way from the server to the client, and then you can do bi-directional streaming. So when you do that, when you get that connection stays open, that's when it's really, really fast. Of course, the downside is if you have 100,000 connections doing that, right? If you think you got 100,000 connections open all at once, just like, and they're staying open. So like anything else, there are trade-offs. But when you do that, is it faster? And use this thing called protobufs that I think Google invented it. They're all about it anyway, to eliminate serialization and deserialization. And now because I don't know how to use Mac, oh, that was, yeah. This is right, this is. So here's the page for gRPC, and so it's grpc.io. So if you want to look it up on your own later, or if you just like okay, and then get up and leave right now, I understand. But that's where, and you know what? So when I do a talk, some people like have everything planned exactly what they're going to say. I plan what I want to tell, and then sometimes I throw stuff in. I feel more comfortable like I know what I'm talking about, or can pretend I do, and just kind of go with it. So that's what I'm doing now. Like I don't have my stuff isn't polished, but I do this as if like we were just sitting around at dinner talking about this stuff, and be, oh yeah, so then protocol buffers, and like so here's an example, and I'll show you some later, but in like actual working sort of examples, but like that's what they are. They're just kind of like a specification, and you pick your language and blah, 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 blah. But I just want to show you it's a real thing. I didn't make it up. It allows any method name, yay, which I think is huge. I think that's a big deal. Everybody else is like, why? And it's machine readable. And so what languages? This is really cool because just recently, like in a couple of, maybe 6 weeks, well, I'm old, so 6 weeks was probably 3 months ago. Because you get older, you lose time. Anyway, JavaScript is new. Like you can actually use it with JavaScript now. So you can actually run your website gRPC calls back to the server. Because typically, and here's where most people go, oh, typically gRPC is used between your services and not to the client. In fact, it was never used to the client until that was done recently. It was all back-end stuff, right? So this service talks to this one, maybe talks to that one, and that's where the speed and all that comes from. You didn't really see much speed to the client. Now you can. But it works in all these languages, which is, I think, pretty inclusive. I don't see any major, Erlang and Rust and stuff, but they're new. Somebody will come up with it. Who's using it? Who cares? But well, what's this called? The appeal to authority or popular, whatever those argument things are. I don't care if Lyft is using it. If it works for me, we bought them recently. Not me, Red Hat. If I bought them, I wouldn't be here. I'd be out on the beach. So it makes life easier. You get machine-readable interfaces and human-readable method names, which I think is a big deal. I think it's a big deal. And protobufs eliminate the need for serialization and deserialization. So that's a theoretical performance improvement. And now I'm going to do this. I'm going to show you, why does that look so, oh, I know why. Oh, shoot, I can't copy and paste. Well, wait a minute. I'm smarter than you are, computer. So this is not gRPC. This is an example of H1 and H2, but gRPC uses H2. So this is an example of the performance increases you get under H2, HTTP2, which gRPC does automatically. You don't have to do anything. It just does it, which is great, because that's another thing you don't have to learn. So, and we have a really great high-speed internet here, so this will be a good example. So here's zero latency under H2 and zero latency under H1. So right away, even with no latency, you saw the difference, right? But what really happens is, remember I said you can open that pipeline with H2. So let's do 200 millisecond latency. So this is what you're living with now on your website. And this is where gRPC really shines, like streaming and photos and things like that. So you saw how long that took. What happens in H2, you only get the latency once. Oops, oh, I blew that one. And then it all comes down. So, right there, it's demonstrably faster. So there's that. I will show you later when it's not faster. Because that's just being honest. I can't lie. So let's talk about performance. So I do with these slides, but I can't remember how far I want to go. Like is this 4 slides or 5? So I don't want to go too far and then give you the next slide. You know what I mean? I'm rambling. I'm glad I didn't get that coffee. So you have an idea. We all have ideas for a new feature, a bug fix, whatever it is, and then it goes into development, and then I know there's staging and all that stuff, but where I worked, it was always idea, development, production. But that was just us. So we have these phases. I simplified them, and so we automate this side, which is great, right? CI/CD pipelines, Jenkins, and there's a bazillion of them, I guess. But Jenkins seems to had the winner. Travis is another one. TeamCity. So like testing, we have all kinds of stuff to automate production. We have testing, automate into production, so on and so forth. But this side, we don't really automate a lot or worry about. Now I know there are improvements to the IDE and things like refactoring and it's built into Visual Studio and all the tools from JetBrains and things like that. So that's not really true, meh. But if I don't say that, it doesn't seem as important about what I'm about to say. But I think, so with this automated,
our biggest opportunity for improvement is over here. And I think the next step that we can make that improvement, and I believe this because if I didn't, then gRPC talk wouldn't be as good, is the communication between two developers. Let me explain something. Years ago, my mentor told me this. A software program is not a communication between a person and a machine. That's not what it is. A software program is a communication between a developer and another developer. And if you go at it with that mindset, you will write really clean code, your comments will be concise, and you'll do a really great job. Even if that developer is you 3 weeks later, at least you come in and go, what? And if you ever went to somebody else's code, went, oh my gosh. But if you have that mindset, it clears everything up. So I think the huge opportunity for performance improvement is making cleaner code. Because the performance gain is the less time you spend going, what in the world? And more time going, oh, I see what this does. And in fact, that's the whole, the argument behind microservices is that you write these really tiny programs that when you open it up and they're that long, you can go, oh, I can see obviously what it does. Was anybody here for my containers talk Thursday? Good, so I can tell this, you were. I can tell this story, it's my favorite. Has nothing to do with gRPC, it's microservices, but it's going to reinforce that point. There's a tool called Wunderlist, and Microsoft bought them a few years ago. And it turned out that some people thought they bought them because of their expertise with microservices. Wunderlist, it's a to-do list, and it had like 200 microservices. It was some ridiculous number. And I saw an interview with like the founder, and his favorite story that he's talked about their microservices, he said they have one part of it that was written in Haskell. And in microservice world, you're supposed to own your code, right? I mean, you own the code. It's 3 o'clock in the morning, something goes wrong, you get called because doggone it, you wrote it and you own it. So the idea is you keep you're really short. Like I had one that was like 38 lines of code. So they call the guy, they can't get a hold of him, he's on vacation or something. So they call another developer, he's a C# developer, he doesn't know Haskell. And like, you have to fix it. So he just rewrote it in C# in 15 minutes. So that's the whole idea with microservices. I have a talk, I wish it got accepted here. It's called Let's Kill the Microservices Hype, because I just think it's just hype and we need to kill it. But there are some good things. So this is a note to me because I have so much stuff on my machine all over God's green earth. So that's where I would know to go. So let's go look at some stuff. And where should we start? I want to start with the protos. Yeah. I want to I apologize for the goofy colors and stuff, but anyway. So code, yeah, right. You really care, don't you, Don? But anyway, so here is a very stunted. Remember I told you about the proto buffs. So this is the part about gRPC I really don't like. And I just never liked this in any language. It's one of those things where you write some code and then you generate code, and the first line in the generated code is, this is generated code, do not edit it. I always hated that. It just felt like so dirty, like so I'm creating this source code that I have to like use. Like why doesn't it just do it? I hate that, but that's gRPC for you. So, of course, Java is an idiot, so it has to have its own options. Only Java would do that. Well, we need stuff for Java. Great, thanks. It would be so much cleaner, but no, Java has to get involved. Because, right, it had that lines of code, right, because Java. So this package is called Hello World. So the way proto buffs work is you have a source code. This is your spec. This is your spec for your system. This is language independent. This is like you do it once. This is your database schema, if you will. You do this once, and obviously until you need to change it, but you do it once and then you're kind of done with it. So that's not too bad. So we have a service greeter, and it has a remote procedure call called say hello. And it takes a hello request and returns a reply. That seems rather simple to understand. So a request is a name, and the reply is a message. So I'm going to say hello, name equals Don, and returns probably hello Don. Given that it's hello world, I'm just going to guess that. The number here is just, you just number them 1 through 2048 or whatever it is. That I don't want to go into all the details of it, but that has to do with the sequence that they're returned in, which is invisible to you as a developer. However, if you make changes or want to remove something, like if you had email equals 2 and address equals 3, and later you wanted to remove email, there's a, a reserve word. You can say reserve 2. So it takes it out, but it keeps the space in there. And if you think about it, I think the way it works, totally a guess, is it returns the bits, the binary, and I think each of these is probably an offset. Like, you know how like if you ever did DOS fat tables, you had, so like 1 is, and then that's a pointer to the first one, and 2 would be a pointer to the second one, and 3 to, I think that, I'm just guessing that's probably how it works. So when you do reserve, you kind of keep the same structure. So later if you want to go back in there and put something in there, it's not mucked up, so to speak. There's obviously websites and all kinds of stuff on this, but that's a real simple one. So then from this, you do one of 2 things. You generate code that you then use, or if you're using like Node.js, it has a library called gRPC that reads this, and because Node isn't compiled, right? So it does it on the fly from this. So, for example, if I go over here, there's a program called Greeter Server. And so I use C#. Yeah, I could use any language. I have a bunch of Node stuff too. So here's what happens in my C#. So I'm using gRPC core, so I have to use that. But here's remember the proto thing that I compiled? And I'll show you how you do that. So I'm using hello world. But this is what's really cool. This is my code. Instead of what I want to show you. Instead of gets and puts and that, I'm actually using, I don't know if I should point or highlight. I'll highlight like this. I'm going to say hello so you can see what it does. It's an asynchronous call. So remember, it's going to return a reply. So I have a new reply, and then the message is hello plus request name. There's a person. I set the full name to foo. Down here's a list. It gets 1,000 of them. It creates a new person, which was defined in that proto file, and then it awaits for the response. This is not really a great example because you don't get the IntelliSense stuff. I'll have to get another one. I do have another one. Oh, there it is. So there's the code, the main code. I'm running on localhost. I'm running it insecurely because it's just this. So that's the server. Oh, I know why this is, because I beg your pardon. The client side looks a lot better. So I should be able to run this .NET new .NET run. I can't type. .NET Core App 2.0. So that should launch and run on, is it 50,051 or 5,000? I don't know. 50,051. Now here's the client side of it. Oh, and ls code program. So you open up a channel. A channel is not a connection. It's just like reserving where you're going to go. You know what I mean? So it's localhost. And you can see on top of there, sometimes I run this example in the web. In fact, I had spun up a server in Korea because I wanted to get a long, I'm drawing a blank. What am I trying to say? A long latency. Thank you. Long latency. And then, and I couldn't get .NET to run on it, so like, screw it. So I created a new greeter client that uses that channel. And here's where I can, so this is like this. This is really cool. So I have person's request. That's going to get 1,000 of them. So down here, like if I'm typing p2 equals client dot get. Why isn't that? Okay, there. So it's starting to come up. That's not. it doesn't matter. I thought when I hit dot, I'm supposed to get IntelliSense. I'm not. So there just goes that whole argument. Have done it. You do get it. The cool thing is you have all this. These are all like, what am I trying to say? It's get persons, not just get, right? So it's get customer. It's do this and that. So it can actually use real names. Let's run it. So this is really interesting because if you run this, .NET run. So this is an example that comes from them, and it's made to run on different frameworks. So that's why I have to specify the framework. So here's what's really interesting. So you run this, and it's like anything, it has to wake up. And I think it's doing, is it 100 times 1,000 calls or something? So it took 1.7 seconds. I think it's 100,000 on my system. Now here's a RESTful interface. And we're doing the same thing. Okay, wait for it to stop. Because this is where you do the performance, right? This run on 5,000, localhost 5,000. Oops, that's not what I wanted. So obviously, you probably can't see it, but the rest is actually faster than gRPC. So just blew my whole argument. And there goes my talk, and that was a waste of time. But so the first time I did this, I was like, well, this can't be right. So then I went in and I tweaked the code so it was faster. And I'm like, that's cheating. And I'm like, no, this is good. Because it's not always faster in terms of production, like speed of getting things. Like this is just getting objects, like persons, right? It's again a bunch of JSON objects. In that case, it's not, and C#, by the way, is optimized for RESTful stuff. I don't know if you know that, but I think it was .NET 2.0. They had like some ridiculous, like 50-fold increase in speed for that. I mean, it's really fast. So it's not always faster in terms of getting things. Again, streaming, pictures, it's faster. But for just regular stuff, it might not be. So now you as a developer, and as like if you're a manager of a shop, you have to decide, well, is it worth being able to call our method names, you know, get customer? Do we just do that because it's nice? Because it is nice. Or do you say, well, we'll use it when we're streaming and we won't use it for this? So there's some testing. So if you remember at the beginning, I said the idea of this talk was not to convince you, it was to show you, because it's not always better. That's just a fact of life. So one of the things that happens is that those proto files, that we looked at that proto file that had the hello world, is you have to build source code. So here's that proto file. And this is because there's different versions, but Proto 3 is the most current one. And these are notes to myself, obviously. I want to show you how that works. Oh, boy. CD. So bear with me while I type. So I have the different protos, and then I can run this command. And what this will do, and this is like really super anticlimactic, because you run the command, and then that's it. So it's kind of a dumb example, but that's the command you run to create that C# file. Notice here I have C# out. So you can, to show you, proto C is the protobuf's compiler. So you can see there, you have to specify which language you're going to, and you can do multiple ones at the same time. You don't have to run it once for each one. But obviously, Node is not on there because that's done at runtime, and it's a library. So that's basically how you do a gRPC. You do that proto file, and then you create the code, and then you use it like in Visual Studio or whatever. It's a C#, you reference the project, and it's good to go. You can change the buffer, like you can add to it without, it won't break your old stuff, which is nice. So if you add fields to it and then later go back, you won't break anything. Here is another example. I think this is my own contrived example. Now, hang on a second. CD up, go up. So, greeter's client. Oh, that again. This might be the same one. I get so many terminal sessions, I get them confused. Yeah, I'm going to show you the code I have. It's my contrived example. Yeah, I think that's where I was. Come on. Yeah, this is what I wanted. I don't know if it works with the server I have. We'll see what happens. No, that's the same one. Forget it. It doesn't matter. What I wanted to show you was a different proto file, and I may have lost it. And I also wanted to show you the code that outputs. Here is the code that's generated right there. And where are the? It's not easy to read, but there's the name. So in that proto buff where we had the name as the one field, it's right there. It's a public string, and all this other code goes with it. It generates all that. If you have multiple, I wish I could talk and type. If you have multiple fields, it looks better. What am I trying to say? Oh, help me. Ah. There. So this one is another example of a protobuf, and I had more stuff, and I had full name, phone number, user ID, and email. So you can check for, it checks for lengths and stuff when it passes it around. And if you look at the code it creates up here at the top, you'll see it, it's got stuff to make sure that it's not empty, or if it is empty, how to respond. And somewhere up here is where they're listed there, I guess. It's all through here. The point is, it generates this code for you, and then you use it in your project. So one of the questions I get is, like, how do you manage that? And that's, I guess you have a central repository where you do that. This is a management issue. I'm kind of like out of stuff to show you. It's not real. It's not real mind-blowing. Yes, go ahead with your question.
With protobufs, if you need to pass around like a description file of what the format is there, how would you manage that if you have like distributed systems or like multiple clients and you need to update the format?
That is the question I get all the time. It's like, so like what do you pass around? Like do you,
the client needs to know the format.
Exactly. Well, yeah. So I guess the thing you would share would be the proto file, right? Not the generated code. In other words, what you would share, how am I trying to say it? Like the specification would be the proto file. Mm-hmm. That you would share. The danger of that and would be that it's like, so if you have that file and it's available to everybody, if somebody changes it and generates code, they're going to have different code. So, and that's what I was saying earlier. That's a management issue. You just have to manage it.
You need to update the clients and the server. You need to update everything at the same time if you're updating the data definitions.
If they're going to use the new stuff. If they're not, you don't. Okay. Now the server you probably do, right? Because it's going to have new clients, but you don't have to change the old clients. But remember earlier I said, like, I hate that thing where you generate code, and because that's why. Because if I get the proto file and you generate code, and I have that C# code, and I'm using it, and then somebody changes it and generates new stuff. Now I have two of them, or like now we're like a source code version of DLL hell, so to speak, and that's so gRPC is not like a be all end all. There are some definite negatives to it. I don't understand why you just can't take that CS file and compile it to a DLL and use that. And I'm asking, I don't know, why not? There's a question in the back.
Yeah, so when you generate code, does it generate like actual files that get stored in like your package?
Yes, yeah, that's right. Okay, good. Yes, I wanted to show you. So this is, son of a gun. I have stuff everywhere. C#, and then, so there's this hello from CLI example. And of course I picked the worst color. But if I go to, you know what? If I open the solution in Visual Studio, it becomes really, that's what I should have done. I still could. But here's the code it generated. So there's two of them, and I'll show you the hello world. This is the one that gets me. Here's the hello world gRPC, and where is that? There. That's the thing that bugs me every time I see it. But yes, it generates these files, for example, and here's all the stuff that it generated for that, and it puts them in that. So there's a project. Oh man, you can't see that. It's at the bottom. There's a project, and then one is the gRPC like methods and stuff, and the other one is the actual just the class. And then there's it's obviously been compiled. But yeah, that's what it does. It generates that code. And so if you open it in,
it just generates the CS file, not the project file.
it generates the project file.
Oh, it does?
Yeah, it generates everything. Yeah, you start with nothing except for that proto file. And for other languages like Ruby, it generates everything it needs.
But JavaScript, you just pass the protocol, the file itself. You don't have to.
Yeah. I haven't done JavaScript. I've done Node, and I slightly, but see. So yes. So in Node is unique. You have two options. You can have dynamically generated or statically generated. So you can generate the code ahead of time and then use it, or you can have it. I think there's a flag or something that does it like when you start it, which gives you, I guess, the latest and greatest. That seems scary to me, but maybe not. But it does the same thing. It'll create the package JSON and everything. So if I go to dynamic code gen, there's the README client. So if I'll do code. So here's the Node.js side of things. So it's not anything great to look at. But anyway, that's how that works. Other languages, it generates all the parts. Yes, I'll come back to you. Yes.
I guess a question about like does authorization differ in gRPC? Whereas like, you know, in a RESTful world, right? I might have a front end application that takes a JWT job and
you would do the same thing. Okay. If the flag that I have here is for the create insecure, I'm just bypassing security for demo. But yeah, you'd have to get a token and use that. And if you don't do that secure, then you pass the token in your code. Yes.
So that's generated file. It references your local host. Is that
This is generated.
This is not generated file.
This it was generated and I changed it, I think, because this is the this is from. No, this one is not. How can I say it? This is not generated code. This is the one that does, like when you run this, it will generate the code. Like the Node.js dynamic generation, you never see the code it generated, right? So if I go into the static one,
It's pointing straight to the proto file.
daggone it. Yes, it's pointing straight to the proto file, where if I go into this, and this is interesting because I literally have never gone into this one. there should be more stuff here. Yeah, so here that we have like gRPC. Boom. Oh, I got, see it? Ah, come on. Where is it there? See the very top, the first line? So the dynamic one, you never see this. So the dynamic example I showed you was written code that creates the dynamic. This is, and this is what it would create, but it does it at the last minute. There's something else I wanted to tell you. I can't remember what it was. But that's basically gRPC. It's fast. I don't know why when I didn't get the IntelliSense, but I know that I do in Visual Studio. It's pretty slick. Once you, like in any other C# class, once you reference it, you get the IntelliSense, which is really nice when you're writing code. So you're like, you have client dot, and up pops your list of available methods and properties. So, and you can pass parameter, you can obviously name the parameters whatever you want, which is nice. There's some wonky stuff with upper and lower case, and it really shows itself in Node. Like in that proto file, everything's lowercase, but then when you use it in Node, it does the, is it Pascal case where you go lower and then upper, like full name, or well, that's a bad example, but like email, address, you know what I mean? So it does some weird stuff with upper and lower case. You can't put uppercase in the proto file or something. I ran into that. So and I don't know the exact rules, I apologize, but you're smart, you'll figure it out. You'll be like, oh, that doesn't work. And then you'll try something else and it works. Hey, that works. That's where I am with it. I'm just like, I know it works if I use lowercase, so I'll stick with lowercase. But that's basically gRPC. I apologize, this isn't the most dynamic demo, but it's, you know what? If code works, it should be pretty boring. Code is like investing. It should be really boring. If it's exciting, it's like, uh-oh. I mean, do you really want exciting code? No, not when it's working. And same with your investments. You don't want excitement.
And so does gRPC always use protobuf, or is protobuf just
Yeah, always, always. So that was the other thing that you didn't see in my code. There's no serialization. There's no serialization, deserialization. So that's nice too. You have to get less code. Yes?
So the way I'm seeing that spec file, the protocol, it's almost like wisdom, how we generate.
Yes, yes. It's the return of WSDL. It's exactly what everybody says. I forgot to make that point. Yes, it's WSDL all over. So then that starts the whole, well, isn't this just Corba? Isn't this just SOAP? I'm like, you call it what you want. But yes, it is a lot like the WSDL. And so the way you would manage that, I guess, is how you would manage this.
Another thing with protobufs, it's a lot more smaller bite size. So your packets were going to be much
Yes,
smaller.
yes.
You're sending around a lot of messages, and they're all like the same objects. Protobufs are going to be a lot more network efficient.
But don't forget what I said earlier. You have regular messages, but then you have streaming up, down, or bidirectional. And that's where you really see, again, when I did the thing where you pull down the JSON with the person, there was no advantage. And I've done it where I've run it like on machines, like in the Far East and stuff with high latency, and it might be a little faster, like you're gonna build your network that way. But sometimes it's not always faster. When I do a lot of testing, it's usually like even, until you get into streaming or pictures and that, and then it just blows away rest. I mean, it obliterates it. It's that's when I'm starting to think, maybe it is 50,000 times faster, because when you start streaming stuff, it's a huge benefit, huge. I mean, that little picture we did was a little thing. Imagine streaming a video file. Man, it flies. That's why Netflix uses it. Anybody familiar with a thing called Istio? So Istio is what they call a sidecar container that works with Kubernetes, and it manages communications between services that run in Kubernetes. And it's very powerful, and it's very fast, and it uses gRPC. So I think the fact that, I said who cares, but the fact that a lot of those industry leaders are using it, and the fact that Google's using it in like high performance open source stuff, and Envoy and Istio, Istio came from Envoy or includes Envoy, and that came from Lyft. So these major guys recognize that it really is fast. So it's just another thing to keep in your back pocket as a developer. If you have a lot of back-end services, you're probably going to have somewhere you could benefit from it. Otherwise, it's just something you know about. And when somebody brings it up, you go, yeah, I saw a really lousy talk on that. Any other questions? Then I'm done. Thanks.